Number 43. A major textile dye manufacturer developed a new yellow dye. Exciting! The dye had a percent composition of 75.95% carbon, 17.72% nitrogen, and 6.33% hydrogen by mass, with the molar mass of about 240 grams per mole. Determine the molecular formula of the dye. Okay, so this is not going to be hard, right? We got this, guys. We've done tons of problems dealing with empirical and molecular formulas. In this case, they want us to find the molecular formula of this textile dye, right? But it all stems from the percentages. Now, I don't like how, they gave the percent and then they put the carbon next door here, right? So just know that, they go together. It's 75.95% carbon. But looks like we have three elements here, and we have to find a molecular formula from a percent, so we can find the molecular formula from an empirical formula, right? We know how to go from a percent to empirical formula. Now we just got to go one more step further to find the molecular formula, but it's a total of a 5-step process, which is this one. Now let me just make this a little bit smaller. I'll put this up here, but this is basically what's going on. You could always find a molecular formula all the way from the percents by following this 5-step plan. If you guys remember these steps for your test and quiz on empirical and molecular formulas, you guys are going to be golden. So the first thing is we got to start with the percents, right? They gave us 3 elements, so let's write them down. They said that we have 75.95% carbon. We have 17.72% nitrogen, and then we have 6.33% hydrogen. And actually, let me just space this out a little bit more, just because I have a little bit more room. Okay. So how do we go from a percentage to grams? Well, the first thing is always make sure that every percentage is accounted for. What's the total percentage, right? When you take an exam, what's the max score that you wish you would reach? It's 100%. So technically, if I add these up, I should get a 100% total sample. And I do. It's exactly 100. So now I can assume one thing. I say that if I have a total percent of 100, I can say that the textile dye snippet that I took of, right, to do this analysis was a total of 100 grams. That would mean that the individual percents would equal the individual grams. So in that case, the percentage just equals the gram amount. That's how you go from percentage to grams. So this, I will say I have 75.95 grams of carbon. This I have 17.72 grams of nitrogen. And then this one I now have 6.33 grams of hydrogen. First part, done. Moving on to step 2. I got to convert those grams into the moles. Whenever we convert grams to moles, right? Remember, we've done tons of problems like this already. It's just a conversion factor, right? AKA a ratio. So a conversion factor or ratio is just taking whatever number you have and multiplying it by some type of ratio that has a number on the top and a number on the bottom. Numerator and denominator. So I'm just going to do that for all 3 of them. And I like to work with the units first, and then I go back and I plug in my numbers. So always start with what you have, right? You don't want the grams of carbon anymore. So that unit will go on the opposite side, aka in the denominator. And the same thing for the rest of them. Grams of nitrogen go on the bottom. And then gram of hydrogen, because I don't want it, that goes on the bottom. The unit that I want is moles, and that's the unit that goes on the numerator, on the top. And the elements have to match. So this would be mole of carbon, carbon goes with carbon. Mole of nitrogen, nitrogen goes with nitrogen. Mole of hydrogen, hydrogen's got to go with hydrogen. Now what are going to be the numbers, right? That's when we go to the periodic table of elements, and we take those mass numbers. The mass numbers is the average mass, right? It's the decimal values on the periodic table. Now, guys, just remember, these numbers go with the gram amount. But if you're taking these numbers, you always have 1 mole of that element. So for example, 1 mole of hydrogen equals 1.008 grams of hydrogen. 1 mole of carbon equals 12.001 grams of carbon. And then 1 mole of nitrogen equals 14.01 grams of nitrogen. So when you're doing that conversion, you always have 1 mole of carbon, 1 mole of nitrogen, 1 mole of hydrogen, and the numbers on the periodic table go with the grams. So for the carbon, it's 12.01 grams, nitrogen is the 14.01, and then the hydrogen is the 1.008. And now the unit grams will cancel, not the numbers, just the units, and that's cool because we want the unit of mole, so we're good. Okay, so let's see what we got. 75.95 divided by 12.01. I'm going to cut it off after a few decimals, so I'm going to say this is 6.324 mole of carbon. 17.72 divided by 14.01. I get 1.265, and that's mole of nitrogen. And then 6.33 divided by 1.008, I get 6.280 mole of hydrogen. And now that step is done. Now we got to get a mole ratio. Well, we kind of already talked about what a ratio is, right? A ratio is the conversion factor. It's just the number on the top divided by a number on the bottom. So if I go over here, for each one of these, I have a number already, right? And that would be the numerator number. But the question is, when I add that division sign, right, or when I put the division sign, what is going to be the number that I'm going to be dividing by for each one of them? Well, look ahead. We want to find the empirical formula first. And the empirical formula is always the most simplified formula of that compound. It's the formula that has the smallest subscripts. So simplified, smallest, keep with that idea. You're going to divide each number by the smallest one out of the bunch. So out of 6.324, 1.265, and 6.280, which one is the smallest number? Yes, this one. So I'm going to divide each one by 1.265. And now I'm going to get some answer. Now at this stage of the game, if you can, round the number to a whole number. So let's see, for example, 6.324 divided by 1.265, I get 4.999. That can be rounded to 5 moles of carbon. The second one is going to just be 1 mole of nitrogen. And then 6.280 divided by 1.265, I get 4.96, which can be rounded to 5 moles of hydrogen. So we are good here. Now I'm going to take those numbers and just make my empirical formula, right? It doesn't matter which element you start with first. I just like to start from the top and work my way down. So my empirical formula, and maybe I can just say EF for empirical formula. My empirical formula would be C. Now, there's a 5 here, right? 5 moles of C, which means that I have 5 carbons. The next element is a nitrogen, and I only have 1 of them, so you can put a 1 here, but you don't have to. And then the final element is H, and I have 5 of them, so I have to put that 5 there. And this is my empirical formula. But the question asks for the molecular formula. So we're almost there. We have the empirical formula. Let's just find the molecular formula. It's only like a one step more to do. What you're going to do is you're going to take your molecular mass of the compound, the molecular formula, and divide it by your empirical mass. And you're going to get some number. Now, let's just do this math. The molecular mass, it's a molecular formula, right? This is also a molar mass as well. So they can say molecular mass, they can say molar mass, and they said molar mass. So in this case, my top number is going to be 240. Now, do I have to put grams per mole? No, you can. It just gets a little bit more confusing. I just like to plug in the numbers because I know that, I'm using the right units. And we're going to divide by the empirical mass. This empirical mass comes from the empirical formula. So now I have to find out what this weighs. And we're going to use the masses on the periodic table. We've done tons of problems like this, right? Just finding how to get a mass. So if you guys are on the playlist and you need more help, you could always just go to previous questions to check out how to do that. But basically, you're just going to calculate 5 carbons, 1 nitrogen, and 5 hydrogens. So let's see if your answer matches mine. 5 times 12.01, that's for the carbon, plus 1 nitrogen, so 14.01. And then I have 5 hydrogens, so 5 times 1.008. Then you add them all up. I'm going to say my mass here is 79.1 grams per mole. So this is the number now that goes on the bottom, 79.1. And let's figure out what that number is. So 240 divided by 79.1. Also at this stage of the game, try to round your answer. And I get 3.03, so I'm going to say that this is a 3. Now, what does this number actually mean? This means that the molecular formula, which weighs 240, is 3 times the amount of my empirical formula, which weighs 79.1. So if my empirical formula is C5N-H5, and I know that my molecular formula is 3 times the amount, I have to just multiply each subscript by that number. So I have to multiply it by the 1. Actually, I have to multiply it by the 5. There was a secret 1 here, right? And the 5. So let's see, what's my molecular formula? Maybe I'll just put it down here, MF. And I'll just say up top here that this is MF. Molecular formula, MF. So 3 times 5 is 15. So I now have 15 carbons. 1 times 3 is 3. So I have 3 nitrogens. And then 3 times 5 is 15 again. So H, 15. And that is your final answer. So this textile dye with, a yellow color has a molecular formula of C15N3H15. And that's it. Guys, what do you think? Let me know in the comments. Give this video a thumbs up if it helped you out. Just gets the feedback back to me that I'm doing my job right and that I'm helping you guys out in the best way possible. If you guys want to help us out, please hit the subscribe button. We're almost at 10,000 subscribers. It's kind of crazy, and I'm so thankful for everybody that watches these videos. I really hope that we're giving you the best possible help that there is. And if you guys are in physics or in math or have friends or classmates in physics or math, go tell them about the channel. We would love to help out anybody that we can. So thank you so much for that, and I hope you have a great day. All right, keep studying hard. You got this. Bye-bye.